We are starting Chapter 3, Section 1 for graphing linear equations. We're going to go over a few kind of specifics on the things that need to happen or the rules for a standard equation. So standard form, we've looked at this before. So ax plus by equals c. So remember, a and b are coefficients in front of x and y, and c is our constant. So some of the rules here that go with this standard form is that c is a constant. It's just a number. A has to be greater than 0. So remember, we've done this before in previous videos or previous lessons. A cannot be a negative number. So if a ends up being a negative number, we need to fix it. And we do that by simply multiplying everything by -1, and it fixes that problem. A and B are not both 0. So one of them can be gone, and you could just have ax equals c, so that means you just have an x term, or a could be 0, which means that x would be gone, so you just have b equals a number, or by equals a number, sorry. Well, in this case, you would solve it, and you just have y equals. So this is the difference between a horizontal and a vertical line, depending on which one you have. If you have both terms, though, they're both bigger than 0, then you're going to have a diagonal line, one way or the other. A, B, and C are integers with the greatest common factor of 1. So this means that we don't want to have something like 3x plus 6y equals 9, which is actually an example we've ended up with before. Well, these are all divisible by 3. So they have a greatest common factor of 3, not 1. What I would do is divide literally everything by 3 and say 3 divided by 3 is 1, or 1x. 6y divided by 3 is 2y, and 9 divided by 3 is 3. So I would just reduce it down so that it has a greatest common factor of 1 now. So that is what this guy means, is that we don't want to have anything where the numbers are all divisible by the same number bigger than 1. All right, I'm going to back that up just so that that's not on my printout here. All right, so those are the basic rules for our equation. An integer is a whole number, not a fraction or a decimal. So that's definitely important here. You want to understand that for integers. They have to be integers, no decimals, no fractions. The greatest number that can be divided into at least 2 numbers. So that's greatest common factor. Sorry, I didn't say that. So that's what we were just looking at. Greatest common factor is the greatest number that can be divided into at least 2 numbers. In this case, it's probably going to be 3, but if by chance B was 0, okay, now we only have 2 numbers. If A was 0, now we only have 2 numbers. So it just depends. It's at least 2 numbers. All right, let's look down here. The next piece of notes on this page is about X-Intercept and Y-Intercept. So this is definitely important for graphing a line. We want to understand what intercept means. So if you're a football fan at all, interception means that the other team caught the ball, right? So same kind of idea here, except we're talking about crossing a line. So Y-intercept is where the y-axis, this is the y-axis, caught the line. So it caught the line right there. It passed over, crossed it. This is the x-axis. Oops, I forgot x. X-axis. And this point, the x-intercept, is where the x-axis caught the line. I'm being silly with my catch analogy there, but it's just where it crosses the line. So that's all intercept means, is that it's where it crosses that axis. And that's important because we can very easily graph a line using the x and y axis. It's one of our methods for graphing a line that we'll practice on the next page here. So if I go ahead and click forward here, the first thing I'm going to do is we're going to go through and determine whether each equation is a linear equation. Write the equation in standard form. So it says each equation because in the book there's actually more than one example. In this case, we only see one. So I gave you a little checklist here to follow on the side. So let's go ahead and write it in standard form just so that we have it. So remember, standard form is ax plus by equals c. So it looks like we have no x term. We only have a y. We have a constant, which is our c, and we have by, right? We don't have x, which means that a was 0. That's what it tells us. And a can be 0. That's actually our first piece. So a is greater than or equal to 0. Check. We can actually check that off already. Because it is 0, that's how that term disappeared. So we just don't have it. So now we want to make sure that we have, in standard form, a and b are not both 0. Well, b is present, it's 1/3, so it's not 0. So check, we can check that off too. Now we want to make sure they're all integers. Well, right now this is a fraction. We need to fix this. So we can very easily fix this by simply multiplying both sides by 3. So now I have 3 divided by 3 cancels. I just have y equals -3. So this is perfectly fine because remember there's a 1 here. We don't have to write 1, but 1 is an integer, -3 is an integer. So this guy passes the test. A, B, and C are integers, not fractions or decimals, right? So this guy definitely passes our test. So we'd say, yes, this is a linear equation. So we just go through that list and make sure it follows all of our rules. All right, the next part we have here says, find the x and y-intercepts of the graph. So if we are looking at this graph, remember x-intercept is where it crosses the x-axis, which is always left to right. Y-intercept is where it crosses the y-axis, which is always up and down. Those never flip-flop. They're always in the same place. X is always left to right. Y is always up and down. So if I look at this line here, and this is the line it wants me to look at, well, it looks like it's a flat line. It's never going to cross this x-axis. So we would say it doesn't have an x-axis or an x-intercept. Sorry, it has an x-axis, but it has no x-intercept. But it does cross the y-axis, this piece here. So it crosses right there at the 150 mark. So we just have to go through and match this up. We want no x-intercept and y-intercept at 150. So I see y-intercept at 150. This works. But that's not true. It's not an x-intercept of 0. That would be right here. So that means that it's crossing right there. It's not crossing right there. So that doesn't work. X-intercept at 150, well, that's backwards. That's supposed to be the y-intercept, so that's wrong. And y-intercept at 0, again, that would be down here. So that definitely isn't true. X-intercept is 150. Again, we just said that wasn't true in the last one. No y-intercept. Well, there is definitely a y-intercept here, so that's not true. No x-intercept. Yay, that's true. Y-intercept at 150. Yep, that's true. So both statements are true, so our answer is J. All right, let's go to the next page here. So we're going to practice some graphing for the next two pieces. Uh-oh, what just happened? Don't know why that flipped over there. Okay, so we're given an equation, and we're going to use the x and y-intercepts for this. So if I want to find the x-intercept, I make y 0. So make y 0. If I want to find the y-intercept, I make x 0. And I know that sounds kind of backwards, but what it'll do is if I make y 0, then y disappears, and I'll have x equals a number. If I make x 0, x disappears, and I'll have y equals a number. So it basically makes that other term disappear is what it does. So let's go ahead and practice that down here. So we'll do the x-intercept first. And, whoops. Intercept. So we have negative x plus 2y equals 3. So I'm going to make y 0. So negative x plus 2 equals 3, and I'm doing that on purpose so that I can use a dramatically different color, so we're making it 0. Okay. So now if I make that 0, well, that's negative x plus 0, which is really just negative x equals 3, right? That cancels away. I don't want to know what negative x is. I want to know what positive x is. So whenever I have a negative variable, I you can think of it as multiplication or division. It doesn't really matter which way you think of this. This is 1. So if I'm thinking of a negative 1x, that's multiplying by negative 1, I'd need to divide both sides by negative 1. And what that does is it just flips the signs. It went from negative to positive. It went from positive to negative. So it just flips the signs on both sides is all it does. So our x-intercept is negative 3. So I can go right to my x-axis here, and I can go 3, and it's going to cross right on that point at 3. All right, and now let's go ahead and do our y-intercept. Intercept. All right, so now we have negative x plus 2y equals 3. Same equation. I don't like the way that negative came out. That's kind of weird. Negative x, there we go. Plus 2y equals 3. And we're going to make x 0 now. So I'm going to leave this open for just a minute. Plus 2y equals 3. And I'll just flip-flop it to red for whatever reason. I'm just trying to make that dramatically different color so we can see that's what I'm plugging in. So negative 0 is just 0 plus 2y equals 3. But really, 0 drops away and we just have 2y equals 3. So we just need to finish solving this guy and we end up with a division operation. Sorry, lost my train of thought. Because it's times 2, so I'm going to divide by 2 on both sides. 2 divided by 2 cancels, so y equals 3 over 2. So sometimes this is a little easier to think of this as 1.2. Sorry, 1.5, 1.2, geez Louise. 1.5, or 1 1/2. Because that's a little easier for me to picture on the graph than 3/2. So I can go 1 and 1/2. It's going to cross right there, kind of in between in the middle. And then I would graph this line. Let's see, can I use my line tool? And I'll do a line here. I don't know if this is going to change the size of the line or not. Let's see. Oh, yeah, change the size of the line a little bit. So I can try to extend it out this way. Boop, there we go. Let's turn the line tool off. And then I would have arrows because this would keep going in both directions like this. So this is how we graph using the x and the y-intercepts. First you make the y0 to find the x-intercept, and then you make the x0 to find the y-intercept. So it's kind of the opposites, right? All right, we're going to try this one more time on the next page here. So let me, I'm going to do my colors again, and I need to make my chiseled marker a little bigger again. All right, so we're going to do x-intercepts first, and then we'll do E, and then we'll do the y-intercept. So 2x minus y equals 2. So remember, x-intercept means make the y 0. So I'm going to leave that open, and I'm going to put my 0 in. Boop. All right, so for this one, I'm not necessarily going to write out minus 0. 2x minus 0 is just 2x. So I'm going to kind of skip that step there, because I know on the last step I wrote that piece out. But really, we don't necessarily need to write minus 0. We know anything minus 0 is just itself. That's an identity. So I can finish this off with my multiplication, or undo of multiplication, which I'm going to divide. 2 divided by 2 is x. 2 divided by 2 is 1. So this is 1x, but we don't need to write 1x. So my x-intercept is 1. So I'm going to go over to 1, and I'm going to put my dot. So that's my first piece. Now my next one, for my y-intercept, I still have 2x minus 3, minus y equals 2. I'm just throwing out all kinds of numbers here. So now y-intercept, we're going to make x 0. Doop, doop. Change my colors again. 0. So I made it 0. And go back to blue here. 2 times 0 is 0. So I'll go ahead and write it down since we didn't have just 0 like we did last time. But really, if you said 2 times 0 is 0 minus y, oh, that's just minus y, right? Or negative y. Remember, we don't want to know what negative y is. I need to kind of give that to the other side. I'm dividing it over. So it becomes positive y and negative 2. Because it flip-flops the signs. And it doesn't always mean it's going to be positive and negative. That's not what I mean. If this were a negative 2 to start with, then it would have been positive, positive. It just depends on what the sign is. So just make sure it flips the sign from what it currently is. All right, so we have y is negative 2. So I'm going to go down to negative 2, and I'm going to put my point there. I'm going to grab my line tool, make my chisel a little smaller so that line's not so big, and boop. And when you're doing this on Alex, you do have some tools that are pretty much like this, where it'll kind of snap the line. All you have to do is click, click, and it snaps the line for you. Mine's a little bit, whoops, I did that really far off. Come on now. Still did that far off. Can't seem to click on the same line here. Close enough. All right, we're going to just pretend like that's close enough. And I would draw my arrows here going. So you're not going to have to piece it together like that on Alex. You just click, click, and it snaps the line for you. A little easier there. My line tool, it's a little hard to judge where I'm going unless I did the slope here a bunch of times, which I could also do. We're going to practice slope, I believe, on the next section. Actually, it might be a couple sections away. We're going to practice slope, but we will learn more ways to do this. But for right now, that was section 1. I will see you in section 2.